Okay, final problem solving. Where do we see these ellipses in the real world? Let's look at a problem. The entrance to a tunnel over a one-way road is half of an ellipse, with a height of 12. That means from the center 12 feet high, and a width of 36. All the way from left to right, the width is 36. The question is, will a truck that's 12 feet wide, 10 feet high, clear the tunnel? Well, clearly, it's low enough. But is it low enough all the way around that ellipse? Because it's 12 feet wide as well. Let's assume that the center for the ellipse in this case is at the origin. Kind of sketch what's going on. If it's at the origin, and I draw a set of XY axes, rough sketch, remember, 12 feet high for the tunnel puts me at approximately the top here. 36 feet wide for the tunnel means that's left to right, means it's 18 on the right side, 18 on the left side. So we're up at 12, we're over at 18, and this I could say is negative 18 since we're on the coordinate plane. If I draw that ellipse in then, I get kind of this archway shape. I have to fit a truck 10 feet high, 12 feet wide into that tunnel. I'm going to center that truck right in the middle. It's 10 feet high, so the truck will be up here in the middle of the tunnel. And if it's 12 feet wide for my truck, that puts my truck 6 feet on either side in the middle of the tunnel. So we could say that this is at 6, that's at negative 6, and this is up at 10. So my truck in the middle of the tunnel might look something like that. Now it looks like from this sketch, yeah, plenty of room. But we need to verify mathematically if that's true. I need to check, are the corners of that truck truly inside the tunnel? As a coordinate point, that corner of the truck will be at 610. So I need to check if the XY coordinate 610 will fit into the equation if I consider this a complete ellipse. Is this arch half of an ellipse as an equation of its complete self going to be big enough to fit that coordinate point? Well, what's the equation of that ellipse if it was a whole ellipse? If it's centered at 0, 0, it's at x squared, y squared for my numerators. Remember, fraction plus fraction equals 1. My horizontal stretch is 18, so my denominator becomes 18 squared, or 324. My vertical stretch is 12, so my denominator, 12 squared, becomes 144. So it's in this equation that I plug 6 for x and 10 for y. That gives me 6 squared, which is 36 over 324, plus 10 squared for y, so 100 over 144. Now if it's equal to 1, if this sum is equal to 1, that means this point is right on the edge of the ellipse. So we need this point to be inside the ellipse, or otherwise, as an inequality, it has to be less than 1 for the truck to fit in the tunnel. Well, if you put this in your calculator, do a math frac and get your answer, that becomes 29 over 36. Is that less than 1? Well, it is. 29 over 36 is less than 1. That means that this point really is inside the ellipse, and so the truck will fit. So answering the question, will a truck that's 12 feet wide and 10 feet high clear the tunnel? I have just proven mathematically that yes, that truck will fit. Done. Yay!